Hello CIS18A. This week I'm going to talk about Unit 4 content. In Unit 4 we are going to cover class inheritance and different ways to control class and subclass. So for this week, please check out the to-do list, and according to the to-do list we are going to cover chapter 6 and 7, so please read the chapter and review the notes. You are to complete lab 4 and also prepare for next week's quiz, which is going to be your Unit 4 homework, which is quiz to review. And also continue to work on your course project. It's important that you keep on working with your project so that way you can complete in a couple of weeks. So for this week, we are going to touch on Unit 4 notes, which is chapter 6 and 7. So in Unit 4 and Chapter 6, it begins talking about controlling access. And as I noticed that some of you posted security concern about your program, a good way to start with the basic security is to look at how your class members are having access to attributes and properties. So one of the things that you need to think about is this particular controlling access process is under the encapsulation. It links the data so that way you can use the instruction in the code to manipulate it. And it allows the members to have different access, not that we want everything public and be able to access all the time. So we're going to go through and differentiate between public and private. And so since week 1, we started working with class in Java, and we saw that we didn't have to put any kind of keyword like public or private. So we were just using it by default, and that will be defaulted to public. But if you wanted to make member to become available to everything outside of its class, you want to be able to use public keyword to specify that the class members are publicly accessible, meaning that it will be able to access outside of the class that you have created. The second area is that what if you don't want to allow access to all the members? What if you want specific member to only be accessed by the methods inside its class? Then you would use private member. And so if you use the keyword private, what will happen is that it's going to make all the members, including the methods, to be only accessible within that class, not outside of that class. So it's important to really think about that when you are designing your program and creating your program for your project and your future classes. So outside of public and private, we need to touch on protected. And so in the protected class, what you would allow is that if there's no access modifier is used, Java will revert back to the default access, which is assumed. So you can also incorporate the protected keyword as you define one of your class. So now on the bottom of page 1, it talks about default access and public specifier. So when you use public in the class, you specify that the members are accessible outside of that class. When you use when you specify private, that those members inside that class is not accessible to other classes. Now, for the default access, it will be considered the same as public unless you have different areas in the packages that you want to group your classes. So the way that we want to control the package is to be able to group your classes together. And we can build package as modular component to your program, so that way it would have different access to different parts of your program, and we can simply import that in. So on the bottom of page 1, it goes over an example program. And in this program, what you have is you have my class. And my class is the first class. It has a private member, int alpha. This will be privately accessed. The second member is int beta. It is publicly accessed. So private alpha, because alpha is not going to be publicly available, it is private. It won't be accessible in another class. Now for beta, since we specify that beta is public, it will be accessible in the second class. Now if you don't specify public or private or protected, what will happen is it's going to default that to public. So int gamma is going to have a default access, which is the same as public. So, but it is a good practice to start thinking about the specifier that you want to use for your members within the class. Now, you can also control your method in many ways. We can make a class publicly or privately available. We can also control the members or variables within that class, and also the methods within that class. And notice in this program, what we see is class access demo. It contains the main function. So in order for this program to work, what we need to name the program is going to be accessdemo.java, and because the class access demo contains the main function or the main method. And within that class, you also see that we have an object called OB, and this object belongs to the first class, as we see my class appears here. So we construct an object OB in the my class, and we wanted to use that object and to access the methods in my class as it is controlled with the specifier. So here what you have is you construct the object, and also you use that object to be able to access different methods throughout, such as set alpha, and then also accessing members or variables such as alpha, beta, and gamma. So here what we see is on the bottom, since earlier we see that beta is public, beta is accessible in the second class for that object. So we initialize and assign that at 88. So beta is accessible. Gamma, since it's default and it's going to be the same as public, that's also accessible. But for the alpha, since alpha is privately specified, what will happen is alpha will not be able to, is not accessible for access demo, because in my class we had specified alpha as private. So as you can see, the arrow points to that line, and that line shows that it is wrong because alpha is private. It's only accessible within my class. So following the program, it gives you the explanation of each of the component in the program and the output. And also in details about private, how each of the area of the private, what is accessible. Now on the second part, we're going to talk about passing object to a method. So the example that's given here, you have a class called block, and you have 3 members, A, B, and C in that class. You also have volume as a member. And also what we want is we want to be able to use the parameter to be able to include the members here. And also we wanted to operate the calculation for volume. Now, how that object is used is what we wanted to specify here is we're going to use the Boolean type. And the object is then going to be used in the parameter as you see on the next line inside the if statement. So now when we do this, what we're doing is we're passing that object to the method. So it's saying if that object is A, the object A is A, and the object B is B, and the object C is C, then return true. Else, it would return false. In the second block, what we have is we have also a Boolean type. And here what we wanted to do is we want to implement the condition for the volume. So again, we're passing the object to the method by using the parameter. So we're saying if the volume of the object is volume, then going to return true, else it's going to return false. And in the second class, what we see here is when we print out the object, what we wanted to do is we wanted to use the specific object OB2, OB3, OB3 as we pass the object to the same block method throughout when we're printing those. So this is how you will be able to pass an object, and this program simply print out the dimension and as it calculates the volume. Now over here under the passOb class, we previously created the object OB1, OB2, and OB3, which is then used to pass into the method. So to pass to the method. So that's what you see as the example program, and what we would have is we would be able to check the dimension between the object 1 and object 2, 2 and 1 and 3, and also to be able to check for the volume. Next, we're going to talk about arguments being passed, and in the notes I specify that there are two ways that the argument can be passed to a subroutine. The first is to call by value, so that the value is copied. The copies of the value of the argument is used in a formal parameter of that subroutine. Second way is to use call by reference, and that way, in this way, we would reference the argument, not the value itself, as it is being passed in the parameter. So when you pass the primitive type such as int, double to the method, it is passed by the value. And we can use that with the call by value. So the first example here is an example of the call by value in which we would use the primitive type. So the first class that you see here is class test. And inside class test, we have a method called noChange. And we would use int I and int j. And then after that, we would define what I is. So I is going to be I plus j. And assign j is negative j. So in the second class, we have call by value. This class contains the main method. We also construct an object called OB, and it is an object of the test class. As you see, test with the test constructor here and the new type. Then we would assign the value to int A and int B. So when we print that out, we would have A and B before call. That's going to be A and B, as it's going to pass down the value to here. Now when we call noChange, when we're accessing the noChange method, we simply include the variable name inside the parameter. So then now AB after the call, it's going to calculate and be able to show the updated values for A and B. as initially it starts at 15 and 20 for A and B. Then we're going to update it by operating this. So, and then it's going to be able to show. So with this, what you have is you have the output for A and B after the values are being passed. Now, that would be the call by value. On the second example, this shows a call by reference. So the objects are passed through the reference. Similarly, we have a class test, and under the class test, we have the members A and B. Now, in this, what we have is we reference A as I and B as J, this is part of the class test. So when we create the method is called change, and we're passing the object to the method. Then we're going to use the object to access A and B, and so that way we would calculate what A is. A is A plus B, and B is negative B. So now in the second class, what you have is you have the pass ref class, contain main method, we have a constructor, and here inside the parameter of the constructor we use 15 and 20. So with this, what will happen is it's still going to display 15 and 20 as output for A and B, but now we're referencing the object to the value compared to the previous example where we actually assign the value within the second class and be able to access the value. So in this case, what we're doing is that when we print out, we're still going to get the same output, but we're referencing, and we're going to call by reference. So it's going to go back to the object, access the attribute, which is A and B, and then be able to pull the value and have that as an output. So important takeaway is highlighted here, and it says that when an object is referenced by pass to a method, the reference itself is passed by the use of call by value. Now, since the value is passed, refers to an object, the copy of the value would still refer to the same object, refer to its corresponding argument. So what will happen is, even though it is a copy of that object, it would still refer to as that same exact object, and it would be by its corresponding argument. Now on the next part, which is returning object, and as these screenshots, if I try to fit it on the page, if it's small, you can pull it larger so you can see. And this is the example represented in the textbook. So in this example, what we're doing is we're actually returning a string object, and we have a class called error message. We have a string array called MSGS or messages, and then within it we have different string: output error, input error, this full, index, out of bounds. So in this, what we have is we have a method called getErrorMessage, and we are gonna use int I as the parameter here, so that way it's gonna bring in, as it accesses that, it's gonna bring in the message or the string that's stored in I. So here what we have is we have a condition: if I is greater than or equal to 0 and I is less than the message length, we're going to return the message, else it's going to show invalid error. Now in the second class, we have a main method, and inside the main method we construct an object called ERR, and it is part of the first class. And what we're doing is we're using ERR to access the getError message. And what we're doing here is we're also using the value to be able when we access the method. So after this program is ran, what will happen is it's gonna pull it's gonna show this is full and invalid error code. So we're gonna have the value to check 2 and 19 here. So if it's greater than or equal to 0, and if it's less than the length, it's going to be able to acquire the string and show that string. Otherwise, it's going to show invalid error code. So in the first print line, what we have is it's checking for the true condition here. So it's able to obtain the third string, this full, and it outputs that. And lastly, on the second one, since even though 19 is larger than 0, but it is not less than the message length, so it's going to give you the invalid error code. So what we see with this one is that you are returning the object, and so you're still going to have the string output as this is a string object. So now on the bottom of that, it also shows another example where it extends this out. In this case, what will happen is that the programmer will define the object compared to the last one. So we have the class called ERR, and we have string message that's going to store our error message. We have a member called severity that's going to store the code, indicate the severity of the error. Now for the next part, what we have is we have the object, and to be able to specify that we have M and S, and be able to use those objects down here in the third class. So in the string, we initialize the string output error, input error, this full, and index out of bounds in the second class. Then we have an array called how bad. This is going to be the severity level, so that way we can check and display the message accordingly. So a program like this would be something that you would incorporate for maybe an OS, maybe an application in case if certain things doesn't work. So now here is where we would have it return an object type. So ERR is the type, and we check the condition. If it's greater than or equal to 0 and it's less than the message length, then it's going to return. This is different than the last one in that we created this. It's going to return ERR, and that's going to pull from the group of messages that we have. Otherwise, else, it's going to return the object, and it's gonna within that we use the value invalid error code. So lastly, this third class contains the main method, which is where we would use to call the other methods. And here we have the object E. We use that object to be able to access getError info and of ERR, and then we are going to display the severity level, and so we use that same object E to access severity. So as you can see, that kind of tie back to the prior chapter on how we talk about constructing the object using the object to access the attributes and accessing the method. And in this case, what we're doing is we are expanding. Now we're going to return the object type. In this case, that will be your ERR. So compared to the last program, this program is returning the object type, where in the last program we're returning the object. Now, on the next one, the next section goes over overloading method. And in my lab, I require that you overload the method, and you would have practice with that in the lab. So please take a look at the lab videos. So for Java, the first paragraph gives you the overall view on what is overloading method. When two or more methods within the same class share the same name, they can share the same name as long as the parameter declaration are different. You can use the same name for the method, but as long as the parameter is different, that's legal. Now, then in that case, what we would know it as is that would be method overloading. And another reference to this is method overloading is one of the ways that we can implement what's called polymorphism. So to overload the method, we simply declare a different version of it. Using type, different type, using numbers in parameters, so that way it would be different inside the parameter, that way we can overload it. Now, when the overloader method is called, the version of the method whose parameter match arguments will be executed. So that's important to think about when you're using parameter for your method. The values and the number of parameters you're using really differentiate one from the other, as you would see throughout the versions of your method that you're overloading. So the following is the example of this. Let's take a look at it a little closer. So we have this method called OVL demo. And OVL demo, the version of the first version we're going to use here, it says the second here, but we're going to have int a. So we would have one parameter, okay? And then it's going to print that under that method. Then we're reusing the same method name, and we're using two parameters. We're using int a and int b. And this is the next version of it, two integer parameters. So that's going to be different than the previous version, as it only have one parameter. On the next one, instead of using int OVL demo, we change up the type and we have it double instead of int. And with that, we use double A and double B. And that's different from the previous version in such that we change the type. So now, simply in the second class, we're using the main, under the main method, we construct the object. Then we would use the object to call different version of the methods. So the first one has no parameter. The second one, we would then plug in the value for int a. Next, we would plug in two values for int a and int b for the third, so 4, 6. And then lastly, we would use the double values, 1.1 and 2.32, as the values for the parameter in the last version. So here what you see is you would see how the same name of the method can be used as long as we change up either the type or the number of parameters. We can then overload that same method in various versions. And so in this program, it would output, so you can see with one parameter it shows 2 parameters it shows 4 and 6, and then 2 double parameters it shows 1.1 and 2.32. Now, keep in mind that when you have different types and when you're returning from the method, it says here that the difference in the return types is insufficient for the purpose of overloading. So therefore we didn't return, but it does do automatic conversion. So in the following example, it shows how you can overload and then how it does the type conversion. So let's take a look at that. Now, this class is called overload2. We have void f, that's going to be our method. The first version we use is int x, and then we simply print that. The second version, again void f, but we change up the type in the parameter, that will be double x, and we print that. Now in the second class we have the main method. We construct the object ob, that's from the overload2. We then initialize the value for int I and double d and byte b, short s. So these are the members of the second class, the variables. We initialize the value, then we use the object to call the method, and then we can simply put in the parameter as we initialize it here. So we would have I, D, B, S, and F. So the first version, that will be the int, that will be called here. So it's automatically going to plug that in as I is an integer. And then D, since that's a double, we specify that here. So 10.1 is going to be used there. And for the next one, that's going to be, because B is byte, and it's going to convert byte to integer. So here, when f is called, the method f is called, but what happened is it's going to convert it as integer is allocated it has larger allocation compared to byte. Then s, since s is short, that's going to also be converted to integer. And also f, it's because f is a float, that's going to convert to the double as we previously have it overload using double x. So what you will see is that it's going to show int, double, int, and double. And float lastly convert to the double. So it's still going to show the decimal values here, 11.5, but it's going to convert up. So it's going to go from the float to the double. So here it gives you an explanation for the example following that. So you can go through that and take a look at it closer. Now, another example where we would use byte, int, and double in the parameter. So the first version, we use byte x for method f. Then the second version, we use int x. The third version, we use double x. And with this, when we initialize here, pretty much the same as the last one. When we do the call, as you can see, the last part here when it does the call, so when it calls the OBF, for the I, that's the integer. For the D, that's going to be double. For the B, that's going to be byte. No type conversion since we had specified byte up here, so it keeps it the same. For the S, it's going to convert it to integer because S is going to be short. and the next one, there's no short type there, so it's going to convert that to integer. And then for the f, since f we have that as float for the type, so since there's no float, as we had declared it for the method, it's going to convert to double. So that's going to be the type conversion, and the next area would show the output and the explanation for that. So method overloading supports polymorphism because it's a way that Java implements one interface with multiple methods paradigm. So some of the things to highlight is following, and I include that in the bullets here. So in languages that do not support overloading, the method must be given a unique name. So they all have to be unique. Now, Java is not like that, where you can use the same name and you just have to use different type. So in that case, right, you want to implement the same method for different data types. Consider the absolute value function. In the languages that do not support overloading, there are usually 3 or more versions of the function in which it would be using slightly different name. So now here it gives you a little bit more explanation on what those statements really mean and how that's applied to C. But with polymorphism, it's noted here that there's no rule stating that overloading methods must be related to each other. However, as far as aesthetic and style goes, method overloading simply implies relationship, but there's no specific rule stating that they have to be related. While you use the same name to overload unrelated methods, it's not the best practice. And there's some examples stating why. So the signature of that method is really the name of the method and the parameter. And so if the two methods within the same class have the same signature, you cannot overload. So you need to either have one that would have the same one and the other that would have the same name, but they have to use different parameter, or if they have they can just simply be different names. Now the signature does not include the return type since it's not used in Java for resolution of overload. You can also overload constructor, and here following that is an example of how you can overload a constructor. So let's take a look at it further. In my class, you have int x member. X is the member, and then we have constructor, my class. And under that, we simply print inside my class, x is 0. Next, we can use int I in the parameter. This is when we overload. So this is the second version of that. My class int I. And with that, we would say x is equal to I. Third, we overload my class constructor again. So we would use double D. And as you can see, first we have no parameter. Second, we have integer for int I. Third, we have double D. And we would say x is going to be int D. Convert that to int. And then lastly, for the fourth overload, we would have int I and int j. We use two parameters as they are both int. And we would say that x is going to be I times j. So now in the second class, we have the main method. We would have the constructor with the new type for T1, T2, T3, and T4. then we simply use T1, T2, T3, and T4 to be able to access member X. And so that way we would be able to output or print, as X would have different values throughout as we overload it. Okay, so this is one way that we can overload the constructor, right? Changing what's inside the parentheses, or known as parameter, the number of parameters, the type of your parameter, and very similar to what we've seen with overloading method. So now in this example, it shows you how to initialize one object with another. So I just want to walk briefly through this. We have a class called summation. We have a member sum. That's an integer. And with the constructor summation, we use int num. So here we have a for loop. In the next part, what we're doing is we use the constructor to construct another object. So we would have summation, and inside the parameter of that constructor, we would have summation OB, and OB is the object name, and its constructor is also summation. So we would be able to construct object from another, and so here we would have sum is the object of sum. So under the main method, we construct S1, S, and S2, and we will be able to use that to access sum for S1 and sum for S2. And as the program output, it shows 15 for S1 and S2. This concludes my video for the first part of CIS18A lecture on access of classes and how to be able to overload methods, overload constructor, and using your arguments. Next, please watch part 2, where we would go over recursion using static blocks, and then looking at your nested class and inner class, and overloading various methods.